Hi again. Sorry we got cut off in the last video. So I was talking about how the sine of x over x, the sine of x is 0, and as your limit goes to 0 of x, you're going to have 0 over 0, which is not defined. So this is a rule that when you have the sine of x over x, the limit as x goes to 0 is defined to be 1. So these you need to know. So you have to memorize these. These are just their value, and then this last one you need to memorize is 1. Alright, so let's try this example. Find the limit as x goes to 0 of tangent of x over x. So now we have the word tangent, which none of those are in terms of tangent. So we're going to use what we know about tangent, and we can rewrite this as the limit as x goes to 0 of tangent of x times 1 over x, right? I have tangent of x and 1 over x. You're multiplying those. So I'm just kind of splitting it up. So tangent of x we know is the same as sine of x over cosine of x. And if we are multiplying that by 1 over x, I'm just going to move my sine of x over here. So I'm going to rewrite this again as sine of x over x times 1 over cosine of x. It doesn't matter what order we multiply things in, so it's okay to move them around. The limit of this now is defined to be 1, and we know that the limit of just cosine of x as x approaches 0 is 1, so it's 1 times 1, which is 1. All right, so flipping to the next page. All right, so what we've discovered is that we can find the limits of many functions by directly substituting in our a value. So in this next section, we are going to look at what happens when we are evaluating limits for which direct substitution does not work. So if you looked at this first problem and you substituted in 1, what happens here is, first of all, ignore this. Alright, so if we substitute in 1, you have 1 minus 1 in the numerator, 1 cubed minus 1 squared, plus 1 minus 1. 1 minus 1 in the numerator is 0. 1 minus 1 is 0, plus 1 minus 1 is 0. You get 0 over 0. So, when this specific instance happens, we are going to factor your numerator and factor your denominator. Something should cancel out, and then you can do direct substitution. So that's what this huge paragraph says. So if the limit of a rational expression gives you 0 over 0, factor it, reduce it, then substitute in your limit. So when we have this case, let's factor. So I'm still trying to find the limit as x goes to 1. X minus 1 does not factor. I have 4 terms. I'm going to factor by grouping. There is a constant, a greatest common factor here of x squared. When I factor that out, you get x minus 1. And then over here, I can factor out a positive 1, and you have the factor x minus 1. Those are the same. So when we factor by grouping, I'm just rewriting, we have the factor x minus 1 times x squared plus 1. Now these cancel out, leaving us with a 1 in the numerator and x squared plus 1 in the denominator. You still want the limit as x goes to 1. Now you can directly substitute in. X is 1. 1 over 2 is the answer, which is what it said there, but, oops, sorry, I've been off the page. So your answer ends up being 1/2. All right, so let's try these. This is a rule you're going to need to know. All right, so let's try. We want the limit as x goes to 1. Substitute in a 1 for all these values. All right, let's evaluate it. You have 1 plus 2 is 3. 3 minus 3 is 0. 1 minus 3 is a negative 2. Plus 2 is 0. All right, so which means we are going to factor this. All right, x squared plus 2x minus 3. Think about what two numbers multiply to 3, combine to give you a positive 2. They have to multiply to a negative 3. So that'll be a positive 3 times a negative 1. Down here, we need numbers that multiply to positive 2, combine to a negative 3. So that'll be a negative 2 and a negative 1. You have a common factor. So now this problem kind of reduces or simplifies to the limit of x plus 3 over x minus 2. Substitute in your value now. You get 4 over negative 1. So your final limit is negative 4. All right, so try these. Substitute in 5. Do your order of operations. 5 squared is 25. 5 times 7 is 35. 25 minus 35 is negative 10. Negative 10 plus 10 is 0. 25 minus 25 is 0. So we're going to factor. I'm rewriting. All right, numerator factors into an x minus 5, x minus 2, denominator x plus 5, x minus 5. X minus 5 reduces out. So we're taking the limit of x minus 2 over x plus 5. Substitute in your value now. 5 minus 2 over 5 plus 5. We get a final answer of 3/10. Last problem, that 2 plus, this should not be there. Ignore this. I don't know why that's there. Get rid of that. All right, substitute in 3. 3 squared minus 7 times 3 plus 10. 9 minus 21 plus 10. That's a negative 2. Substitute in your 3. 3 squared minus 25. 9 minus 25, negative 16. So this limit existed. So I'm just going to keep reducing 1/8. The limit's 1/8. Okay, just because it's rational, the limit still can exist. All right, so now for practice, I think this is where it was supposed to say 12.2. Work on page 910. These problems here, they're all odd. All the answers are in the back of the book. Do a problem, check a problem. All right, have fun, and I will see everybody on Wednesday. Bye.